Fifth grade lesson 7.8 is compare mixed number fractions and products. Our essential question is, how does the size of the product compare to the size of one factor when multiplying fractions greater than 1? Again, this lesson is more about wrapping your brain around what's happening and what to expect on your product. You will, of course, get steps towards doing the calculations and how to do it, but this is helping with the reasonableness of an answer. This is going to help you kind of recognize if something seems right or seems off. Let's unlock the problem. You can make general statements about the relative size, the reasonableness of a product when one factor is equal to 1, less than 1, or greater than 1. So we're going to see what we would expect if we multiply by 1, something smaller than 1, or something more than 1. Charisse has a recipe that requires 1 1/4 cup of flour. She wants to know how much flour she would need if she made the recipe as written, if she made half the recipe, and if she made 1 1/2 times the recipe. So let's have a look at this. We're going to shade the models that show 1 1/4, the amount that we're talking about. We're going to shade that first. So 1 1/4 is 1 full, and then I'm going to cut this one into 4 equal pieces and shade one of those 4 equal pieces to be 1/4. Okay, if I'm doing that 1 1/4 one time over, 1 1/4 one time over, what can I say about the product when it's multiplied by 1? Things haven't changed from our identity property of multiplication, have they? 1 1/4 only one time over is still 1 1/4. It stays 1 1/4. And we know that because identity property of multiplication. So if we're multiplying by 1, if we're doing one level of it, then it stays the same. What about if we do half of 1 1/4? Let's first go ahead and shade the 1 1/4. So if I'm doing half of that, I'd first cut this in half, and that is going to be 1/2. And then I'd also have to cut this in half, which would make that 1/8, 1 out of 8, because you have to imagine that the whole thing got cut that way, that each of the fourths got cut in half. And if I add those together, remember when you add, we need a common denominator. So this is going to be 4/8 plus 1/8 is going to be 5/8. And just visually, you can see that, first of all, we can see this fraction means that it's less than 1. And visually, you can see now it is less than 1. This was one whole, and now we've got just this piece. Let me highlight so that our brains can see it. Just this piece, and then this little piece added to it. So it's not even 1. So half of 1 1/4, or any fraction of the 1 1/4, is going to be less than the factor that we started with. So this one stayed the same when it was multiplied by 1. This one made this number that we were multiplying smaller. Now let's look at if we're doing 1 1/2 times 1 1/4. So I'm going to go ahead and do my 1 1/4 shaded here, and my 1 1/4 also shaded here. What we're going to do with this one is we're going to use the distributive property to kind of pull this apart. 1 and 1/2 is the same as 1 plus 1/2, right? So we're going to take that 1 plus 1/2. We're going to do 1 times this number, and then add that to 1/2 times this number. So we're just pulling that 1 1/2 apart, 1 and 1/2, and we're saying it's 1 plus 1/2, because that's the same amount. 1 and 1/2 is still one whole with 1/2 together. And now we're saying this was times 1 1/4. Okay, now we're saying I'm going to do the 1 times that, distributive property, and then I will add it, that add comes from there, to the 1/2 times the 1 1/4. All right, so we know that 1 times 1/4 left it alone. That's what happened up here. So we still had 1 1/4. I'm going to go ahead and put that there, 1 and 1. Well, I'm going to leave it like that for now. Then I have 1/2 of 1 1/4. So this is what we did right here, right? Where we ended up cutting it half here and half here. And we ended up with half, and that 1/8 there put together gave us 5/8. That's what we had done here, which was smaller than. And we'd have to put those together. So we already know we have this amount. So if we're just having to say, is it the same, is it less than, or is it more? Well, it's this and this part. So it's more than our original factor, 1 1/4. And if we want to know exactly how much, we have 1 1/4 added to 5/8. I can do this as 2/8, equivalent fraction. That's going to give me 2 plus 5, 7/8. 1 7/8 is how much I end up with, which is nearly 2. It is more than that original factor, 1 1/4. So what we have to internalize, if I multiply my factor by 1, it stays the same, identity property multiplication. If I multiply it by a fraction that's less than 1, and I know it's a fraction less than 1, if it's a proper fraction without a whole number in front of it, then it's going to be smaller than this amount. If I multiply my factor 1 1/4 times a mixed number, that means it's times a whole amount and then some, so it's going to be bigger. If that picture version didn't connect with you, then they've given us also this number line version. You can also use a diagram to show the relationship between the products when a fraction greater than 1 is multiplied or scaled, which is resized, by a number. Jake wants to retrain for a road race. He plans to run 2.5 miles on the first day. On the second day, he plans to run 3/5 of the distance he runs on the first day, and on the third day, he plans to run 1 2/5 of the distance he runs on the first day. Which distance is greater, the distance on day 2 when he runs 3/5 of 2.5, or the distance on day 3 when he runs 1 2/5, or 2 1/2 miles? Let's have a look. 1 2/5 of 2.5 miles. So we're talking about 2.5, that's our main factor here, right? And just like before, we have that 2.5 times 1. We have 3/5 of that, 2.5, and 1 2/5 of that. So if you're remembering from the way we drew it in the previous slide, then you'll probably have an idea of which one is the most. Just in case you don't, if that didn't connect, let's see it. We're going to mark 2.5 on the number line this time. So instead of boxes visually modeled, let's use the number line. I'll mark 2.5 with my highlighter. 1 2.5. So I marked 2.5, and 2.5 one time over is, in fact, 2.5. If I went some more, another 2.5, that's 2 times over. So we know that is the same amount as the factor, 2.5. So the product of 1 and 2.5 will be equal to 2.5. What if we did 3/5 times 2.5? So again, let's mark the 2.5 mark. But we only want 3/5 of that. That means that we need to cut this into 5 equal pieces and only use 3 of those. So 1, 2, 3, 4, 5, it's already kind of cut there for us into 5 equal pieces, and we only want to use 1, 2, 3 of those. And so here we end up right here. That is 1, 2, 3 of the 5 pieces we broke this into. And so we only end up with 1.5. So it's smaller. It's a smaller amount than he ran on this day, right? It's a smaller amount. He's only 1.5 miles instead of 2.5 miles. So the product of a number less than 1 and 2.5 is less than 2.5. And if he wanted to do 1 2/5 of 2.5, well, he's now doing the full 2.5 miles. Then he's doing that 2.5 miles again. So we have 1 times 2 1/2. Then he's doing 2/5 of that. Okay, so just so that I know how many of these hash marks I'm going across, broken into 1, 2, 3, 4, 5 equal pieces, I'm going to go ahead and do a real light highlight of the next 5, but we're not going to use all of it. We don't need all of it. Let me choose a color that's real light. 1, 2, 3, 4, 5 of the next amount, but only 2/5 of that, 1, 2, is going to be used. So right to here. So he is now running a total of 2, 3.5 miles. 3.5 miles. So the product of a number greater than 1 and 2.5 will be more than 2.5 and more than the other factor. So 1 2/5 of 2.5 miles is a greater distance than this one up here, which was 3/5 times 2.5. So 3/5 of 2.5. Because we're multiplying by 1 and then also 2/5. And we know 1 gave us the same as, and then 2/5 gave us more than, an additional amount. If it was just 3/5 by itself or 2/5 by itself, it ended up cutting it down. So really what I want you to pull out of this is simply that if I multiply a fraction by 1, or a mixed number, I should say, a mixed number by 1, I'm going to get the same amount as I started with. If I multiply it by a fraction, let's just use a fraction, a proper fraction, one that is less than 1, so the smaller number is on top of the larger number, then it's going to be a smaller amount than the factor that I'm multiplying it by. And if I multiply it by a mixed number, then it's going to be a larger amount than the factor I'm multiplying it by. That's what we want to pull out of this, so that if we work on problems and we recognize and we get an answer, and we can recognize, like, if it comes out quite, a little bit wrong, we can go, oh, wait, that doesn't sound right. Otherwise, we wouldn't know. And there is our kind of a cheat sheet right here. A mixed number times 1 is going to be the same. Identity property of multiplication. Mixed number times a fraction, a proper fraction, meaning less than 1, then our answer is going to come out, our product is going to come out less than the original mixed number. A mixed number times a mixed number, where you have a whole number and then a fraction, it's going to be more than our original mixed number. So we'll keep that in mind, and that'll help us with all of these. Right now I have 5/6 times 2.5, or sorry, 2.1/5. Here is our factor, the mixed number we're looking at, and we're multiplying it by a fraction, the proper fraction. So we're looking at this step here. My product should be less than 2.1/5. So I'm going to put less here. And that's really all they're going to be asking you in this lesson. Is it going to be same, is it going to be less, or is it going to be more? They do have us show how we know that here, or show it so that your brain can internalize it. So let's go ahead and shade in 2.1/5. There's 1, 2, and let's split this into 5 equal pieces. 1, 2, 3, 4, and that one last one is 5. And we're going to get 1/5 there. There's 2.1/5 shaded. I want 5/6 of that. That means now that I need to split all of these into 6 equal pieces. 1, 2, 3, 4, 5, and that last line is a 6. 1, 2, 3, 4, 5, and that last line is a 6. 1, 2, 3, 4, 5, and that last line is a 6. And I get 5/6 of this one, 5/6 of this one, and 5/6 of that one. And that all together will give me less than I had originally, because now I'm not including this, and now I'm not including this, and now I'm not including that, and that's less than it would originally. So yeah, I'm going to have, they took some away from me by doing that. So I have less than 2.1/5. Let's look at this one. We have a mixed number being multiplied by 2 2/3. So what is that going to do compared to 2 2/3, the original factor we're looking at? This is a mixed number times a mixed number. So our answer is going to come out being higher, more than 2 2/3. All right, what about here? I have 2 2/5. How is my product going to compare to 2 2/5? If I multiply it by a fraction, a proper fraction that's smaller than 1, because it's a proper fraction, if I do a mixed number times a proper fraction, my answer is going to be smaller. So this is just all about training our brain to what type of answer are we looking at. Whatever the answer is, it is going to be less than 2 2/5, because I'm multiplying it by a number smaller than 1. 2 halves, remember, is exactly 1. Ta-da! There it is. So if I do this mixed number times 1, it's going to be exactly equal. Okay, and then finally, this example, I have this mixed number. I'm multiplying it by a proper fraction, 2/3. It's less than 1 because it's a proper fraction. So a mixed number times a proper fraction means my product is going to be less than the factor 3 and 1/6. I hope I explained that okay. This is more about recognizing where our answer should be-ish so that we can catch any errors we might make as we're going into the next lesson and then learning the steps to actually calculate them. This wasn't about calculating them. This was just recognizing, oh, I'm going to get a higher number than my factor, or oh, I'm going to get a lower number, or it's going to be the same. So I hope I explained that well, and I hope that made sense for you.